Hey guys, today we're going to talk about our last segment on quadratic equations. We're going to talk about how to solve them via the method called completing the square. For this video, I'm going to first talk about how to do it, how to use the completing the square method, and in another video, I'll talk about why it works. All right, I'll talk about why it works. So, anyway, what's the purpose of completing the square? Purpose. All right. We would like to change the format of our quadratic. So our quadratic equation is given by ax squared plus bx plus c equals 0. Yeah, so we'd like to change this. We would like to change this from the general form all right, this here the ax squared plus bx plus c is our general form to the vertex form. All right, and the vertex form is y equals a parentheses x minus h squared plus k. I don't know if you remember this from absolute values. We talked about this briefly. Here, a tells us how wide the equation is. No, sorry, how wide the parabola is. And then remember, well, we look at the absolute value of a, not just a, the absolute value of a. So large absolute value, smaller, or should I say thinner, a thinner parabola, and vice versa. H in this instance is the x-coordinate of the vertex, all right? X-coordinate of vertex, and the k is the y-coordinate of the vertex, all right? And for the h, remember, you always gotta watch the minus sign. Always multiply by -1 for your h when solving through it. And I know this may sound complicated today, but I promise you, after a few reps, you might see that completing the square is maybe even easier than using the quadratic formula or factoring, all right? But most students don't like it, but I don't think it's too horrible. Anyway, let's get to it. So, let's solve this quadratic equation here, right? I have x squared minus 6x plus 5. Let's see what I can do here. So the first step one is ensure a is equal to 1, all right? If your equation doesn't have a as 1 when solving, right, you have to either factor out a common factor or divide the whole equation by that same coefficient to make sure a is 1, because completing the square will only work correctly if a is 1. All right, so you gotta make sure a is 1. So here, thankfully, a is already 1. All right, so step 1, okay, that's good. Then step 2 would be to get constant to the other side of the equation. All right, so all we're doing is moving the +5 across the equal sign. So we're going to have x squared minus 6x equals minus 5. All right, and then step 3. Step 3 is divide the x term, and in our case, the x term is b, right? It's always b. Divide the x term by 2, all right? So our x term in this case is minus 6x. No, not x, just minus 6, sorry. Minus 6 divided by 2 is going to be equal to minus 3, all right? Then step 4, square your b over 2 value, all right? So if we square it, it's going to be minus 3 squared, and that's going to be equal to 9. Then step 5, add the 9 to both sides of this equation. And I'm going to just draw an arrow pointing you, all right, to both sides of this equation here. You gotta add the 9 to both sides, all right? So we're going to be left with x squared minus 6x plus 9 equals positive 9 minus 5. And then we're going to have x squared minus 6x plus 9 is equal to 4. So now, this quadratic equation has been made into the format of a product of perfect squares, so to say, right? And I can express this as a product of two binomials, right? So basically what I'm trying to say is that I can factor this equation. I can easily factor this equation. And how I'll factor it, it's going to be x minus 3. And this minus 3 comes from step 3, all right? X minus 3 squared is equal to 4. And x minus 3 squared is equal to this equation. And this will always work, all right? The number you get in step 3 is the one you plug in to solve for your equation. And I can show you. If I have x minus 3 times x minus 3, it's going to be x squared minus 3x minus 3x plus 9. It's going to be x squared minus 6x plus 9. Same equation. So, and this here is our vertex form. All right? So here the last step is just to solve. All right? We have our vertex form. Last step, solve. So there we go. We divide both sides. Sorry, we square root both sides to get rid of the square. X minus 3 is equal to square root of 4. Square root of 4 is just 2, right? And this is going to be plus or minus because it's of a square root over there. And then we have two values of x, all right? So if we take the 3 to the other side, it's going to be x equals 3 plus or minus 2, which is going to be equal to, so we have two values of x, right? Break it down like a formula will be 3 plus 2 equals 5, and 3 minus 2 equals 1. And that's how you complete the square. All right, we found our two x values, our roots, our solutions to the equation. So yeah, x1, I can say x1 equals